Okay, let's go ahead and get started talking about tangents. So we've already gone through and seen what a tangent looks like as we just did on our last test. So a tangent is a line that intersects a circle at exactly one point called a point of tangency. So when I say intersect, what I really mean is that it just touches. So we'll write touch. It doesn't go through, but it just touches. Okay? The circle at one point, called the point of tangency. A line is tangent to a circle if and only if it is perpendicular. So it's going to be perpendicular. Remember, perpendicular means make 90 degrees. Okay? To a radius drawn to the point of tangency. So in our picture, it means that AP or PA right here needs to be perpendicular to AB. That means right angle right here. Okay? That's why that box is there. So in directions, or in for number 1 and number 2, what they're asking us to do is decide if it is tangent. What that means is they want to know, is this a right angle right here? That's the question. Which means, is this a right triangle? So if we want to know about right triangles, we need to do what theorem? What is that thing for side lengths of a right triangle? Oh yeah, the Pythagorean theorem. So the Pythagorean theorem says c squared equals a squared plus b squared. Perfect. So that's what we're going to do. We're going to actually write down that we have all the parts, and we're going to see, are they equal to each other? So, in the first one, so in number 1, the question is, which one is the hypotenuse? Correct, it's 17. So we'll do 17 squared equals 8 squared plus 15 squared. So the question is this equal? So you can even put a question mark here if you want. Is it equal? So in your calculator, you can put 17 squared. That gets 289. And then 8 squared is 64. And 15 squared is 225. So now let's just add that right side here. So we get 289 equals, when you add this, so 225 plus 64 gets us 289. So the answer is these are equal. So yes, AB is tangent. So if they are equal, the answer is yes, this actually is a tangent. Not only does it look like one, it is one. Now for number 2, what we're going to need to make sure that we do is, do you notice that BP right here? BP is made up of 2 parts, and we're only given one of them. We have 5 here, but I need to know, how much is this piece here from P to the edge of the circle? Yeah, it's a radius, so it's 11, just like the other radius is right here. So what we're going to do is make sure that when we do the Pythagorean theorem, the right angle should be right here if we have one. Which one is the hypotenuse? Correct, it's 16. So 16 squared equals 14 squared plus 11 squared. So is this true? Question mark. So 16 squared is 256. 14 squared is 196. And 11 squared is 121. So let's add these up. We end up with 256 equals, so let's add those up. So we get a 7 at the end. It looks like it's 317. So this is not equal. So you can put a slash there. It is not equal. So in this one, AB is not tangent. Okay? Now, there will be other times when we need to go through and actually complete the Pythagorean theorem. Luckily, we're really good at that. We've done that about, I don't know, I would venture to say maybe 1,000,000 times. So, in this one, this is asking if JK is tangent, so that means we do have a right angle here for sure. It wants you to find x. So this is legitimately just a Pythagorean theorem question. So we have our hypotenuse, that's x. So x squared equals 7 squared plus 19 squared. So x squared equals 49 plus 361. Now, when I add that, so go ahead and add that, x squared equals 49 plus 361 is 410. I believe, let me pause and double. All right, and it is, so we'll square root 410. And then we need to make a factor tree for 410 like we always do. So 2 and 205. And then 5 goes in there, and 41. 41 is prime, so we have no pairs. So x equals the square root of 410. And you're done. All right. So now for this one, for number 4, there's a special trick that we can use. So one thing that we know is that this piece right here should be 10. But we don't want to go through and call it x plus 10, because if we were to do that, this is what it would look like. Because we want to do the radius. Oh, I'm sorry, not the radius. I would want to do the hypotenuse, which is x plus 10. And we would have to square that, because that is the hypotenuse, or c squared. But I don't think that's a good idea, so we're not going to do that. That's too hard. X plus 10 squared, we would have to FOIL out, like from Algebra 1. So instead what we're going to do is we're going to call it just y. I'm going to come up with a new name for it. So it's going to be y. I'm going to pretend I don't know any part of it. It's going to be really helpful for us to do this. So I'm going to say y squared equals 10 squared plus 24 squared. So y squared equals 100 plus 576. Y squared equals 676. Square root. Y equals, now, actually 676 is a perfect square, so put it in your calculator, the square root of 676. Correct, it's 26. Now be careful, because we don't want 26 as our final answer. We know that the total is 26, and we want to find x. So we have actually x plus 10 equals 26. So we subtract 10 and we get x equals 16. This is probably a way to do this problem that is at least 10 times easier than the way that you would have to do it if you did x plus 10. So we'll practice doing those things. All right. Now, more tangent line properties. This actually gets to be very simple. So what it says is if two tangent segments meet at the same point outside of the circle, then they are congruent. So back to your favorite thing. They're equal. So we can mark them as equal. And we can write it. AB is congruent to CB. Sorry about that. All right. So what we have here is that point B is the point where they meet, and they both touch the circle and are tangent. So what that means is that they are equal to each other. Now, it then says that we have, if a polygon is circumscribed around a circle, all right, around a circle, then all sides are tangent. So what that means is that BD is the same size as BE, so they're both coming from B. And then these two are both coming from C, which means that they're equal. And then we have the ones that are coming from A, and they're equal. Okay? So for number 5, it should be very simple. These two are tangents, so these are congruent. If they are congruent, we set them equal. 8x minus 19 equals 5x plus 23. I'm going to pause. You can go ahead and solve. All right, and I got x equals 14. Now what I do is I look at number 6. So number 6 is actually one of my favorite kind of problems because all I have to do is circle the letter that's on the outside and find its branches that will be the same. So 16 is already here, which means that this one is also 16. Now I'm going to do the same thing. Here's F, and F already has one. Great, 9.5, so its other one is also 9.5. All right, and then I'm going to do it one more time. We've got D, and it has 11, which means it needs another 11. Now, when I go to add these up, what I always do, because I don't want to make a mistake and miss one of my numbers, I know that I have 2 of everything. So I'm going to say I have 2 11s plus 2 16s plus 2 9.5. And then I'm going to add them up. So let's go through, just use a calculator for this. I'm going to do the same. So I'm going to pause and use a calculator. And there we go. The perimeter is 73. Okay? So what we're going to do is we're going to save the back side. We're going to do that as our warm-up in class next time. All right? So that's all for tangents. Please make sure that you've copied all of this down. And if you have any questions, come in to ask. Thank you.